So we have the topology. As you can see here, we have four nodes. Okay, out of four nodes, the two nodes are sending nodes, and one is the receiver, that is N0, node 0, and node 1. These two are sending nodes. And node 2 is the intermediate node which connects this N0 and N1 to the destination node, that is N3. Okay, and again, here after connecting these nodes, we should also create some transport layer agents. That is, at the transport layer, we have two main protocols like UDP and TCP. And here we are using UDP protocol at the transport layer. So, for all the sending nodes, we have to create UDP agent. That's why for N1, we are creating UDP agent named UDP1. And for N0, we are creating UDP0. Similarly for N2, because this is also an intermediate node which forwards the information to the destination, we are creating UDP2. And then each node has to generate some data, and that data must be forwarded to the destination. For that, we are using CBR, an agent called CBR, that is constant bit rate. Okay, so for N1 we are creating CBR1, and for N0 we are creating CBR0, and for N2 we are creating CBR2. Actually, here after creating node 1 and configuring, we will create this UDP agent and we will attach this UDP agent to the node. Then after that we will create CBR agent and we will attach this CBR agent to UDP agent. Okay, like that, same thing for node 0 and node 2. Okay, create UDP agent, attach it to the node, then create CBR agent and attach it to the UDP agent. For the destination, we are using a different agent called null agent. So we have created a null agent named null 0 and we are attaching that to node 3. Now let us see the different steps in this program. So these are the steps involved in this program. If you remember these steps, you can just substitute the code segment for each of the step. The first step is to creating new simulator. Here in NS2, we have a class called simulator class, and that class contains all the necessary member functions and variables which are required for our simulation. So we have to create an object of this class simulator. Then setting up the traces. Here our animation file will generate some trace values and those trace values should be stored in a file. So for that we are setting up those traces. Then we have to write a procedure called finish procedure. That is step 3. After that, we have to create the nodes. As you can see here, we have 4 nodes. So we have to create 4 nodes. Next, set up connections. Once you create independent nodes, we have to connect them. And we have to mention the type of link we need, whether we want bidirectional link. If it is bidirectional, then it will be a duplex link. Or if you want simplex, that is unidirectional link, that we have to mention. But here for our program, we want bidirectional link. So we want duplex link. Then bandwidth. We have to define the bandwidth between the nodes, and delay, that is propagation delay, we have to define, and queue type. Okay, next, define queue size. So here basically we will be having two queues or two buffers from node 0 to node 2. For this connection, we have one buffer, and from node 1, N1 to N2, for this connection, we have one more buffer. So two buffers are there. The maximum size we can define. That is sixth step. Next, the seventh step is to create the transport layer connections and traffic sources. So here we have to create UDP agent and CBR agent. The transport layer agent is UDP agent, and in the application layer, we want to create a traffic source. For that, we are creating CBR agent. And for each of the node, we are creating these things. You can see here in the seventh step, set up transport layer level connections for the sender. That is for node 0, set up transport level connection. That means create UDP agent for node 0. Next, set up traffic source for the sender node 0. After creating UDP agent for node 0, then we have to create CBR agent. That is our next step. Okay. CBR is the constant bit rate. So whatever the rate you define, if you define 500 bytes for the packet, then all the packets will be having the same size, 500 constant. That is for node 0. Okay. In the same way, we have to create one UDP agent for node 1 and one CBR agent. That is for all the sending nodes, one UDP and one CBR agent you create. Similarly for node 2, create UDP agent, then create CBR agent. But node 3 is different here because that is the destination. For that, we don't need UDP and CBR agent since it is not sending any data. It is simply receiving the incoming data. That's why we define another special type of agent called null agent. Okay, only for destination. So after all this, we have to connect the source nodes with the destination nodes. Here our source nodes are N0 and N1 are the source nodes. So we have to connect N0 to N3. Okay, then we have to connect N1 to N3. And we are not directly connecting N0 to N3 and N1 to N3. Instead of that, we will connect it through the agents. For N0, we are writing UDP0 as the agent. So UDP0, we have to connect it to the agent of N3. Okay, so here the agents are interconnected, not the nodes directly. So connect UDP0 to null 0 and connect UDP1. It is the agent of node 1 to null 0. Okay, yeah. That is what the next step says. Connect source nodes node 0. That is, it has UDP 0 as the agent and node 1 has got another agent UDP 1. These two will be connected to the destination node 3's agent, that is null 0. After this, schedule and start the sources. We have to schedule the simulation and we can start running the we can make the source nodes send the data. That is about ninth. So these are the main steps in this program. Okay, now let us see each step. What is the corresponding code for each of the step? Let us see. The first step is creating new simulator. Okay, that is our first step, and here it is. Creating new simulator. We have a class called simulator. So of this type, we are creating an object NS. So to create an object, the command is set command. Okay, we have to use set command in NS2 to create an object. So we are writing set NS and of we are instantiating the class simulator. So inside the bracket, we are writing new simulator. Next, the second step, as you can see here, for each of the step, we have written code now. Setting up the trace files we have to set up now. For that, we have these four statements. The first one, set nf open lab1.name in write mode. Here we have to create one animation file, okay, because we have to run the animation. So we are creating an animation file with the name lab1. Extension must be NAM for animation. lab1.nam in write mode we are creating, and for this we are giving a descriptor. The file descriptor for this file is called nf. So it is nothing but create a file descriptor named nf, and what it is pointing to, it is referring to the file lab1.nam. This is what the file name we are giving. Okay, next, $ns nam trace all. See here, nam trace all is the member function which is available in the class simulator. So if it is available in the simulator class, we can't directly access the member function. If you want to access the member function of this class simulator, it must be through the object of the simulator. Here simulator's object we have created just now, it is NS, is the object. So we have to use this object to access the member functions of simulator. And how to access, how to use this NS? While creating an object, you can write set NS. But afterwards, to refer this object, we have to use dollar symbol. Okay, that's why the dollar symbol is used here to access this NS. So we are referring to name trace all through this object. Okay, dollar NF we are writing. So it means that record all simulation traces in NAM input format. Okay, that is NAM. Whatever this NAM generates, everything we are recording. That is called NAM trace all. All input animation traces will be recorded. Okay, next. Set TF open lab1.tr in write mode. When we run the simulation, it will generate some output, and that we want to store it in a trace file with the extension .tr. So we are creating a trace file open lab1.tr in write mode. Okay, and for this we have given a file descriptor tf. Then we are writing trace all is a member function in simulator class. So use this $ns to access this trace all function. $ns trace all $tf, that is all the trace values should go to the file pointed by the descriptor tf. And where this tf is pointing to, this tf is pointing to, here you can see it is pointing to lab1.tr. So here we are saying indirectly all the trace values should go and stored in lab1.tr. That is about setting up the traces. Next, then we have procedure finish. Finish procedure we have this PROC is a keyword. It declares a function, a procedure. Okay. So the procedure name is finish. In this we are writing global NSNFTF. So these object names NSNFTF, these are declared outside this procedure. That's why we are writing global. Next we are writing flush trace. Flush hyphen trace. It is a member function in our simulator class. So we are using $ns to access this flush trace function. And this flush trace, it is a simulator method to dump the traces on the respective files. Okay. Then close these $nf, $tf. Those files we are closing. Now we are executing our animation file. Execute animation file NAM. The name of our animation file is, here we have given lab1.nam. So here also you should give lab1.nam. Then exit 0. So now this will end the application and it will return the number 0 as the status to the system. So 0 means clean exit. So this is about the procedure finish. Next. So now our next task, if you look into these procedures, the next step is to, the fourth step is to create nodes. We have to create nodes. How many number of nodes? In the topology, we have 4 nodes are there. So these 4 nodes we have to create by using this set n0. That is, create a node named n0, and we have a method called node, a member function called node in the simulator class. So to access this node method, we are using again $ns. Okay. So of this type, we are creating a node. Similarly, node 0, node 1, node 2, node 3. 4 nodes we are creating. And remember, before opening any square bracket, you have to leave a space in NS2. So by using these statements, create the 4 nodes. After that, Next, we have to set up the connections between the nodes. Now we just created independent nodes. Now we have to connect them. And how we are connecting? $ns duplex link. Again, duplex link is a method. So to access this method, use this object ns. Then link between what? Which nodes? We want link between node 0 and node 2, because here you can see from node 0, yeah, node 0 is the sender, and to reach destination it has to go through node 2. Okay, that's why we are creating a duplex link between node 0 to node 2, and we will also create duplex link from node 1 to node 2. Then we will create a duplex link from node 2 to this node 3. So these three duplex links we will be creating now. Okay, node 0 to node 2, n1 to n2, and n2 to n3. Yeah, here duplex link from node 0 to node 2, and we are defining bandwidth 200 MB and propagation delay 10 millisecond. Then drop tail is the type of queue, because sometimes the buffer may become full, that we call it as overflow. If there is overflow in the buffer, it will start dropping the new packets. So if we write drop tail, it means that whichever the packets that arrive at the end at last, they should be the first ones to be removed from the buffer, to be dropped from the buffer. So last arriving packets will be dropped first in case if there is any overflow. That is the meaning of drop tail. So next also we are doing the same thing between node 1 to node 2. Okay, you just mention bandwidth, delay, and queue type. Then again from node 2 to node 3, we are giving 1 MB bandwidth, 1000 millisecond delay, and drop tail. So after this, now we have to define the queue size, okay, between the sender and the intermediate node, because here our intermediate node is N2. This node has to store the incoming packets because it is receiving data from two nodes, but it is sending data through only one link. So it has to store the packets temporarily in the queue. Then what is the queue size? For each connection, there will be a queue. From node 0 to node 2, we will be creating one queue. From node 1 to node 2, there is another queue. Now we want to set the maximum number of packets each queue can hold. That we are setting here. That is define queue size. Okay. For that, we have a function called queue limit. It's the function in our simulator class. So between n0 to n2, we are writing maximum 10 packets it can hold. Then we are writing queue limit from node 1 to node 2. Okay, that is both the sending machines to the intermediate node. The queue size we are defining. So this is about define queue size. After defining the queue size, what is the next step? Here, set up transport layer level connections and traffic sources. It means you have to create UDP agent and CBR agent for all the sending nodes, and you have to create null agent for the destination. That is our task. So for node 0, node 1, and node 2, we have to create both UDP agent and CBR agent for each of the nodes. And only for node 3, we have to create null agent. Let us see how to create. Yeah. First, for node 0, let us create UDP agent. So how to create? Set followed by the name of the UDP agent. We are giving UDP 0. Okay. And new agent slash UDP. That is, we have a class called agent. In that, we have another subclass UDP. Of this type, we have created an agent, an object, UDP 0. Next, after creating this, we have to attach it to the node. So we are attaching this agent to N0, one of the sender, by using attach agent method. Again, this attach agent method is available in simulator class. So you use the object NS to access this method. Then we are attaching UDP 0 to node 0. Next, we have to set up the traffic. We have to generate some application traffic. Okay, so that is done through this CBR agent. And how to create? Set CBR 0. So we are creating this object CBR 0. The class name is application, in that traffic, again in that CBR. This is the class. This we are instantiating by writing CBR 0. Next, for this CBR 0, we are setting parameters like packet size and interval. This is constant. So once you define 500, it will be applicable for all the packets because it is constant bitrate. So packet size equal to 500 and interval. Here, for the entire duration of the simulation, the sender will be sending continuously the packets to the receiver. Then what is the interval between the packets? That we are mentioning 0.005 second is the interval between the packets. Next, CBR 0 attach agent UDP 0. So before we created first UDP agent, right? This UDP agent, and before that, first we created node 0. Then we created UDP 0, this agent. Then we attached UDP 0 to node 0. Afterwards, we created this CBR 0. Okay, CBR 0 we created. Then we are attaching now attach agent CBR 0 attach agent UDP 0. CBR is now attached to UDP 0. So this is the procedure here. Create a node, then create UDP agent, attach this UDP agent to the node. Then you create CBR agent and attach this CBR agent to the UDP agent. Okay, you are not directly attaching CBR to node. Instead, you are attaching CBR to UDP agent and UDP you are attaching to the node. In the same way for node 1. For node 1 also, first create UDP agent, give it a different name. Now we are giving UDP 1. Then you create CBR agent. Now we are using CBR 1 as the name. After that, attach UDP 1 to node 1. Okay. Yeah. So we have already node 1. To this node 1, we are attaching UDP 1 is attached. Next, we are creating CBR 1 and this CBR 1 we are attaching to UDP 1. Okay. And here we are not defining the packet size and interval because if we don't mention here, it will take the default setting. Okay. If you want, you can repeat the same here also. Like interval packet size also, it can be defined, but we are ignoring. We are not writing here. So after writing for node 1, for node 2 also, we have to do the same procedure. For node 2 also, first create UDP agent, then attach UDP agent to node 2. Okay. Anyway, we have already created node 2. Then we are creating UDP2 agent. Then we are attaching UDP2 to our node 2. Now we are creating CBR agent by name CBR2. After that, we are attaching CBR2 to UDP2 agent. Next, we have one more node, node 3. Node 3 is our destination. We don't have to create UDP or CBR for node 3. We have to create a special agent called null agent. This is defined like this: set null 0, new agent null. Okay, in agent class, we have another class null. So of this type, we have created an object null 0. Now we are attaching null 0 to our node 3 destination. So all the nodes are now ready. Okay, we have established all the transport layer connections. Next, we have to connect the sending nodes to the destination. Our sending nodes are node 0 and node 1 are the sending nodes. And final destination is node 3. So we are connecting node 0 and node 1 to node 3. But we should not mention directly the name of the node. See here we are connecting node 0 to node 3 and node 1 to N3, that is node 3. But directly you should not write N0 to N3. Instead, we have to mention the name of the agent. The name of the agent for N0 is UDP0. This we are connecting to the agent of the node 3, that is null 0. Again, agent of node 1 is UDP1. So we will connect this UDP1 to null 0. Okay, that's what is written here. $ns. So connect is a, as I again, member function in our simulator class. So we are using ns object to access this connect function. What we are connecting? UDP0 is connected to null 0. Again, UDP1 is connected to null 0. It is like N1 is connected to N3. In this statement, N0 is connected to N3. Okay, that is the meaning. Now we are scheduling the simulation and we are starting the source machines to send data. So $ns at 0.1 CBR0 start. Okay, CBR0 means node 1 will start. At time t equal to 0.2, CBR1 will start. And at time t equal to 1.0, finish the simulation. Next, run. Okay. So this is about the TCL file. So when you write the TCL file, this is how we have to write it. So when you execute it, while creating, we will use gedit filename.tcl. Then after creation of the file, we will execute. For execution, we will use the command ns command. Ns followed by filename.tcl, we will write and execute. Once we execute, it will generate a trace file. If we open the trace file, it will contain values like this. You can find some 11 columns. Okay, so each row corresponds to one packet. So there will be thousands of rows will be there. That means thousands of packets are sent from source to destination. And here in this program, we have to calculate the number of packets dropped and where, how to know which packet is dropped. For that, we have to check the first column. See here, the first column in the trace file. The possible values here are plus. Plus means this particular packet is at this point of time added to the queue. Minus means the packet is removed from the queue, or the packet is received by the node. Then D. D means this particular packet is dropped from the queue because of overflow. So now our task is to count the number of Ds. How many number of Ds are there in the trace file? Since there will be thousands of rows will be there in the trace file, it is difficult to count this manually. For that, we are writing another small program called arc program. Okay, that arc program will do the text processing and it will do this task. So here is our arc file. The arc file mainly contains three sections. Begin section, then we have the body of the arc, next we have end section. So in the begin section, you have to write the keyword begin, then opening bracket, then closing bracket. Within this, you have to initialize all the variables. Here we are using one counter, c equal to 0, we are initializing to count the number of Ds. Okay. Then here is our body of the arc. In this, you have to open the bracket and close the bracket. Within this, all the processing statements will come. Here we are writing if $1 equal to D. $1 means the first column in the trace file. See, here we have the trace file, column 1, 2, 3, and so on. Sorry, column 1, 2, 3, 4, like this. The first column is the status of the packet, event. The second one, time. Next, from node to node. Then we have CBR. CBR means the type of packet. Then we have like other parameters, length of the packet and all this. So if the first column is equal to D, it means that that particular packet is dropped. So that we are considering, then we will increment our count. Then we will print $5 and $11. Okay, percentage, $5, $11. $5 means fifth column, $11 is 11th column. Our fifth column is CBR. See here, in this there will be different types of packets sent like acknowledgement, TCP packet and all. But we want to count only CBR packet. So we are checking for CBR in this. And 11th column, the last one, will give you the length of the packet size. So those two we are printing. So this it will process. Okay. Then end section. After processing until it reaches the end of the text file, it will do this task. Then at last, it will print this. All the printing statements, we can write it in the end statement. That is after processing the final result which we want. The number of packets dropped equal to %D C, because C is our counter. It will be whenever it encounters the letter D, it will be incremented like 1, 2, 3 like that. So this will give us the total number of packets dropped. Okay, so this is the awk file. So execution procedure I have separately given. There is a separate video. There is another playlist that contains execution demo for all the simulation programs and also all the Java programs. You can refer that. And yeah, I can give the link in the description box. I'll mention the link. And also if you want more detailed, some more explanation, you can refer this file. This file also, the link I will provide in the description box. So for each line, you can find explanation here. Okay. I'll just provide the link in the description box.